Hello everyone, and welcome back to another adventure in electronics, robotics, and communication systems. Crypto hashing is a topic I brought up in the past, mostly in the context of cryptocurrency, but the idea goes a lot farther than that, and if you're doing any type of hardware level security, you're going to like some of the projects coming up next. But for just today, I'm going to demonstrate exactly what a crypto hash is, and I'm doing so using computational software called GNU Octave, which is a free open source computing platform very similar to MATLAB. The code today has been tested in GNU Octave version 5.1.0. As explained on the GNU website, and I'll paraphrase, it's often necessary to find out if two strings or files are identical. We certainly could compare them one character at a time, but this is slow, and a hash gives us a better, faster way to do this. We can think of this as a function where we feed in a string, and by the way, today these strings are usually ASCII or Unicode, and then out of this function we'll get a sequence of characters, which represent a collection of raw binary bits. By definition, a hash is a one-way function, meaning that there's no reasonable way for us to reverse this process by starting out with a hash and working backward to get the string that created it. Moreover, the only way to know what hash you're going to get out of some data that you can put in is to simply try it. Let's do that now by opening Octave, waiting for the command prompt to load, and typing hash SHA-256, hello world. Here, the first parameter must be the name of the actual hash that we want to use, so we essentially need to choose it from a table. The second parameter is simply whatever string we want to hash. Press enter, and as its output, you can see a string of hexadecimal characters that, when decoded, expand out into a 256-bit sequence. We can do this again using variables, or classes as they're called in Octave, by creating a class called myString, assigning it the string value of hello world, pressing enter, and then requesting a hash on that string object. This time you can see that the hash is exactly the same as before, and experimentally we can repeat this for every hash function that the software supports. Finally, if you want to hash the contents of a file, Octave makes this fairly easy, so you essentially just take the second parameter, type in fileread, and within parentheses and quotes, enter the name of the file. By default, fileread will pull the file from the working directory, and the working directory is simply a directory that you choose when you configure Octave. Press enter, and once again we get the expected result. The power and the convenience here is this file can be virtually any size, and yet its cryptographic hash will always map to a volume of information that is always 256 bits wide, assuming you're using SHA-256. Semiconductor firms have dedicated chips that can act as peripherals and then carry out these same hash functions on the circuit boards of ordinary electronics. If you would like to see this done here, leave your feedback and be sure to like and share the video. This channel is currently small, but that also means your feedback is going to have a large impact. If you are holding cryptocurrency, be on your guard because there are a lot of phishing attacks going on, so it is best to have a security mindset. Follow-up videos on PinePhone and ChatGPT are currently on the way, so stay posted, stay safe out there, and as always, have a great day.